All right, section 7-4, similarity in right triangles. All right. So the altitude of a triangle is a segment from the vertex to the opposite side that is perpendicular to the opposite side. In an isosceles triangle, the altitude of the base divides the triangle into two congruent triangles. Circle the altitude of triangle ABC. That would be line segment CD. So geometric mean. For any two positive numbers, a and b, the geometric mean of a and b is the positive number x, such that a over x equals x over b. So the geometric mean of 4 and 10 is the value of x in 4 over x, which equals x over 10. Or cross multiplying, and you get x equals 2 root 10. All right, so which proportion can you use to find geometric mean of 5 and 15? Well, by definition, it's C. The geometric mean of x of a and b is x equals the square root of a times b. So the geometric mean of x, geometric mean x of 3 is 7 is square root of 21. So what's the geometric mean of the square root of 3 and square root of 3? And that's going to equal the square root of 3. Okay. So the altitude of a hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and then to each other. So if I have an altitude, I actually have similar triangles to all of them. So all of these things are similar. So that means AD is to XD, which is XD to CD. So if I'm looking for a geometric mean here, X, okay, then what I have is this little relationship here, okay? If I'm looking for the sides, so if I want AC, so I have this X, then I'm looking for this relationship. And if I have this side, I'm looking for this relationship, okay? So if triangle LMN is a right triangle with right angle LMN, NP is the altitude of the hypotenuse, completes similarity statements. Okay. So we know that triangle LMN is similar to triangle LNP. LMN is similar to triangle NMP, and LNP is similar to NMP. All right, so which following sets this up? This is corollary 2, this is corollary 1, and this is corollary 2. All right. So write the names of the similar triangles. RPQ, PQS, and PRS. All right, write the three right angles, RPQ, QSP, and PSR. And the smallest angles are QRP, SPQ, and SRP. So triangle RQP is similar to triangle PQS. Triangle RQP is similar to triangle RPS. And triangle PQS is similar to triangle RSP. All right, let's try some problems here. Use the justification below to find geometric means. What's the geometric mean between 4 and 18? We first set up this definition. 4 over x is x over 18. Cross multiply, we get x squared equals 4 times 18, which is 72. Taking the square root, simplifying the square root, which is the same thing as the square root of 36 times 2. The square root of 36 is 6 times the square root of 2. All right, so x is the largest, it's the length of the leg largest triangle, so we're going to use corollary 2 to find the value of x. Y is the length of the altitude of the largest triangle, so we're going to use corollary 1. All right, so we're going to first write the proportion. Then we're going to cross product. Then we're going to take the positive square root. And then we're going to simplify. Okay. So place an X by the statement that it's correct, a check by correct, and X if it's incorrect. All right. So I know the length of the hypotenuse of triangle ABC. Yep. I know the length of the segments of the hypotenuse of triangle ABC. Yep. I know the length of the altitude. I don't. I can use corollary 1. Yep. All right. So we're going to set that up. Okay. So I'm going to use a circle method, and I'm going to set that up as follows. So I'm going to set up X is to 9 as 16 is to X. So cross multiplying, I have X squared equals 144. So X equals the square root of 144. So X equals 12. There we go. All right. So the hypotenuse is RT. The segments of the hypotenuse are RP and TP. The segment of the hypotenuse adjacent to leg ST is TP. All right, and that's the end of that section.